Let's say I asked you to differentiate the following function. Y equals to x squared plus 1 and all in brackets to the third power. How would you differentiate this? You might think that, well, this will look like, okay, power rule, I can just swing over the exponent, 3x squared plus 1, and obviously it's 3 minus 1 up here, so this just becomes 2. And we're done, right? Is this correct? Nope, not correct at all. Here's why. You did the outer part, which is great, but you didn't look at the inside guy, right? Inside the bracket, what's going on? We have an x squared and a plus 1 here, right? We can't just neglect that in our differentiation. So there's a new style of, differentiation we have to learn now, and I'm going to show it to you. So, scrolling down, it's called the chain rule. And this looks really weird, but trust me, it'll make sense. Basically, we're using a composite function. So if you remember composite functions, composite function is basically putting another function inside of a function, just embedding it, right? So that's what's going on here. We're saying, let's say if we had f and then g of x in it, so f and then g of x, we put it in for that x value, right, over here. And if we differentiated this, what would that give us? That would give us f prime of g of x multiplied by g prime x. Really weird. I know that seems a little daunting at first, but it'll make sense in this proof I do, hopefully. But the way to think about it is, in this first part, you're differentiating the outer function, which is f, and then you're keeping the g of x the same when you're embedding it. And then the next step you would do is you would differentiate the g prime of x. So you would differentiate this middle guy over here. And then you just multiply it all. So that's sort of like, the bare bones way to understand it. I'm going to show you a proof and then hopefully it'll make sense. So in this notation, chain rule is basically this. Differentiating y with respect to x is the same thing as saying differentiating y with respect to u multiplied by differentiating u with respect to x. And the reason this makes sense is, well, these du's can just cancel out, right? Because they're in the denominator and the numerator. And then you just end up with dy over dx. So that's chain rule. We're sort of doing, we're treating maybe perhaps a function into a composite function to differentiate appropriately, right? Just like how we saw with with product rule and quotient rule, right? We sort of treat them separately, right? Because we're always doing f of x and g of x, even though it might just be one function. So that's just sort of the idea. So I'm just gonna undo all this. So let's get into the proof. Let's say I said in this first step, right here, I'll call this step 1. I'll write it right here. In step 1, I say, okay, let y equals this composite function of f equaling to g of x, right? And then now differentiating y with respect to x is simply, now I'm just going to use the difference quotient here. This is just the difference quotient. I'm just plugging in, the x plus h and the x over h values, stuff like that. Let me zoom out a little. All right, so that's step 2. Now in step 3, I do a little algebraic manipulation. This orange you see, right? If you divide the top and the bottom, you just get 1, right? This just becomes 1, right? But I introduced this so I can get something. Normally in proofs or trying to find some things, you have to do some sort of algebraic manipulation, and you sort of have to just think about it. It doesn't always make sense. That's just the nature of doing proofs and everything. So I just, this is just manipulation, algebraic manipulation. I just added something in, and I'm just multiplying this existing thing we had here by this guy now. So I did that. The next thing I do is I swap denominators. Since we're multiplying, I said, okay, if I can just push this h guy over here and this g of x plus h minus g of x here, which gives us this. You can totally do this, right? Because you're just multiplying. It's the same thing. And they still cancel out. This part and this part can still cancel out, right? And then I'd still get the original thing I was getting. So no wrong moves yet. So now we get into a little bit more complicated. So we just use the limit property. We just expand the limit, we multiply it by this, and and then we multiply it by this guy, right? Now the limit of h approaching 0 of this whole thing is a little messy, doesn't make sense. But the limit of h approaching 0 for g of x plus h minus g of x over h, well, we've seen this before. This is the difference quotient that gives the derivative. So that's what we get. We get g prime of x. Because if you forgot, I'll write it for you. The limit of h approaching 0 of, let's say, f of a plus h minus f of a over h. This just equals to f prime a, right? So just the difference quotient. So that's what we do. So now we have g prime of x, but we still have this really messy guy over here. This really messy term. No idea what to do with it. So again, we do some more algebraic manipulation. And I've symbolized this on the left here. So I say, okay, let's say we let k equal g of x plus h minus g of x, okay? And we rearrange this to say that g of x plus h equals to g of x plus k, right? This is, one equation now we have, or whatever, right? And then I say another thing, because I'm saying a lot of things to make this seem more neat and clean and crisp. I say let u equal g of x. So now we have two things. So now using 1 and 2, using 1 and 2, we get this guy. G of x plus h equals to u plus k. If that doesn't make sense, just look at what I did. G of x plus h equals to g of x plus k. I'm saying u equals this guy, so I'm just putting u plus k here. So that's basically it. So I substitute that all into here. So, and then also the limit changes entirely, right? Because now I'm saying, whatchamacallit, why am I having a brain fart? I'm getting rid of the x plus h with g of x plus k, right? So I'm getting rid of the h, and now we say k. So we've introduced k. So the limit as k approaches 0 of f bracket u plus k minus f u over u plus k minus u. Again, I'm just substituting everything, and pause the video and just look at what you're seeing if it doesn't make sense. I'm just substituting it in, right? Once I've substituted it in, I just simplify it, and now guess what? The limit of k approaching 0 of f u plus k minus u over k, well, we've seen that again. That's just the difference quotient that gives us the derivative. So now we have f prime u times g prime x. Now you may be wondering, okay, how does that sort of, equal something? Well, when we have a function, let's say of g prime of x here, right? If we were to express it in a certain notation, we would say, well, that's just, dy over dx, right? Now in this case, we're doing something, and now for, let's say we had f prime of u, which we do, we would describe this as dy du. So differentiating y with respect to u. And so f prime u times g prime of x is the same thing as saying differentiating y over with respect to u multiplied by differentiating u with respect to x. It's just the same thing as up top as I had here. That is the proof of that, right? And if that doesn't make sense, well, if I substitute everything back in, so let's say I substituted 2, so this was 2, let u equals g of x, right? U equals g of x, so I plugged in for u, I plugged in g of x, right? And that gave me f prime g of x multiplied by g prime of x. So that is the proof of the chain rule. Hopefully that made sense, but I thought it would just be nice to show you the derivation so that it makes a little, sense to you as to why we do this. Again, there is, some mathematical rigor behind it. It's not all made up. All right, let's go through some examples. So question 1 from the top. Y equals to x squared plus 1 to the third power. So the way we do this is looking at this guy over here, or I can just write it out again. I'll write it in pink. F of g of x differentiated gives you f prime multiplied by g prime of x, right? So f of g of x prime gives you f prime g of x multiplied by g prime x. So what does that mean? Well, we can treat some things as an outer function in this case. So the way I like to think about it is, okay, I'm going to carry over this 3 here, right? Because that's just the power rule. And what I'm doing outside of the bracket is the outer function. So it would look like this. 3 x squared plus 1 times 2, right? We're not done. This is just f prime. Let me do this in the colors. This is just f prime g of x, right? That's all we're doing. This is the outer function part. Now we have to multiply g prime of x. What is our g prime of x? Well, this guy in here, this can be treated as our g of x. And this, you know, let's pretend there's just a 1 here, right? We can just call this like our f of x. A way to think about it, right? So now we just did f prime g of x because we left the inside. We did not change this, right? Unchanged. And we just derived outside of the bracket. Sorry, not derived, differentiated outside of the bracket. That's all we did with bringing over the exponent. Now we're going to multiply the derivative of g of x, which is this inside. And well, what is the derivative of this inside? So I can write this as x squared plus 1 and then that comma. So then this would give us, or I should just make an arrow like this. Okay, so y prime would give us 3x squared plus 1 to the second power multiplied by differentiating this to give us g prime of x, right? So the 1 is just a constant, so that just becomes 0. This is 2x, right? We're going to bring over the 2, so this becomes 2x. 2 minus 1 is 1, so 2x. So we just write this as 2x. And then we just multiply it. 3 times 2x, that's just 6x. X squared plus 1 squared. And that would be the derivative of that. So the idea is basically the differentiation you do outside of the bracket, treat that as the f. And then differentiation you do inside the brackets, that's the g of x. So hopefully that makes sense. Just try to keep that idea in mind. You know, what we do outside of the bracket is f of x. What we do inside of the bracket is g of x. Let's look at another example. Let's say I had y equals to x cubed minus 7x plus 1 to the 4th power. Pause the video and see if you could try this. So, differentiating this, we're going to swing over the exponent. So first we're going to do the outside bracket stuff, aka we're going to do the f prime g of x stuff first. Meaning we keep the inside bracket stuff same, we are just differentiating outside. So I'm going to swing over the bracket, this would become 4. Then I'm keeping the inside bracket the same. Now for, you know, minus 1 up here, that's just 3, but we're not done. Now we need to include the g prime of x. So now we're differentiating the inside stuff. So differentiating x cubed minus 7x plus 1, all of this differentiated. So this would be 4x cubed minus 7x plus 1 to the 3rd power multiplied by the derivative of 3x is just 3x squared. The derivative of negative 7x is just negative 7. The derivative of 1 is 0. That's what we get. And so you don't have to expand all this. If you want to go ahead and have some fun, if that's what brings you joy, but I'm just going to leave it like this. And that's, you know, totally fine, right? We can just leave it in this factored form. So 4 times x cubed minus 7x plus 1 to the 3rd power, all of that, multiplied by 3x squared minus 7. That is the derivative of that. Pretty funky stuff. Let's do another one. Let's say I gave you this. Y equals to 1 over x squared plus 1 to the third power. So the first thing to do would be to write it in, bring this denominator up top, just try to write it like this, x squared plus 1 minus 3, right? Now we can just differentiate this, swinging over the exponent. Negative 3 x squared plus 1, we're keeping the inside the same first, right? Negative 3 minus 1, that's negative 4. Now we're multiplying by g prime of x, right? So this is the gx, this is the f outside of here, right? So x squared plus 1, differentiating that. So this gives you negative 3x squared plus 1 to the negative 4 power multiplied by 2x. And then you get negative 6x all over x squared plus 1 to the fourth power, right? Because 2 times negative 3 is negative 6. And then there's a negative 4 here, so that means it must go under the 1. And so that is what you get, negative 6x over x squared plus 1 to the fourth power. Let's do another one. This one's going to be a challenging one. Maybe, maybe not. Let's say we had y equals to 3x minus 1 squared multiplied by x plus 1. Pause the video and see if you can try this. So, you may have noticed this, you may have not, but we are going to also use the product rule. So now we're going to use chain rule and product rule because it's no fun when you only use one rule. We'll make it more fun with 2 rules. So how does this work? So if we recall product rule, right? I'll do this in the yellow. Product rule, f of x multiplying by g of x. Differentiating that would give you f prime of x, g of x, plus f of x, g prime of x, right? But now we're also going to apply the chain rule to this because we see we have a term with parentheses with an exponent to it, right? So we have to apply the chain rule as well. So applying the chain rule, so this would be the first term, right? First term you're dealing with. So this would be f prime of x, but within this we have a g of x and an f prime. So the way I'm just going to write this first is just 3x minus 1 squared. I just put this brackets around it to indicate I'm differentiating this. X plus 1 plus 3 of x minus 1 squared, then x plus 1 multiplying and differentiating that. Now differentiating 3 of x minus 1 to the squared, we swing over the exponent. This becomes 2 times 3 of x minus 1. Right? This just becomes times 1, and then now we have to differentiate 3 of x minus 1. So 3 of x minus 1, differentiating that, no, not a 1. All multiplied by x plus 1, plus 3 of x minus 1 squared, because differentiating x plus 1, right, that just gives you 1, right, because the 1 becomes the 0, and then x is just 1. So we don't have to write the times 1 there. Now, this would be, so I'll write it like this, 3 of x minus 1, right? Now, differentiating 3 of x minus 1, that just becomes 3, so this would just become 6 multiplied by x plus 1, right? Because this just becomes, differentiating this becomes 3, and then you just multiply it. 3 times 2 is 6. Right, plus 3 of x minus 1 squared. If we can do some factoring here, we can factor out a 3x minus 1, which gives us 6x plus 1, 6 times x plus 1 plus 3x minus 1. And so we get 3x minus 1, 6x plus 6. Actually, I'm just going to be a little more quicker. So 6x plus this 3x here, that becomes 9x. 6 times 1 is 6, subtracting 1 plus 5. And that is the derivative of that. Let's do one more. One more for funsies. Calculus is fun, right? This one's a little bit of a challenging one. All right, x squared plus 12 over x plus 2 to the fourth power. So x squared plus 12 over x plus 2 to the fourth power. Pause the video and see if you can do this one. So, right from the get-go, I'll be straight with you. We're going to be using quotient rule with chain rule. So the last example, we used product rule with chain rule. Now we're going to use quotient rule and chain rule. So if you've forgotten, quotient rule, or you know, if you have f of x over g of x, and you're differentiating this wonderful thing, this is just f prime of x, g of x, minus f of x, g prime of x, over gx squared. Yikes, I can already tell this one will be a fun one. So the way to do this, and there's a few ways to do this, but there's just one way I like to use. It's basically, I just use, like in the last example, how I just use product rule and then I use chain rule. Now I'm just going to use quotient rule and just throw in chain rule. So f prime of x, so this guy up top would be our f of x. This guy would be our g of x, right? So differentiating this, x squared plus 12 to the fourth power being differentiated, multiplying by x plus 2 to the fourth power, subtracting x squared plus 12 to the fourth power, differentiating x plus 2 to the fourth power. So x squared plus 12 to the fourth power, multiplying by x plus 2 times 4, differentiating that, all over x plus 2 to the fourth power because we're squaring that, so that would become the eighth power. Yikes. Not too bad, we can totally do this. Let's tackle this guy. So I'm gonna sort of circle this in yellow and write it in yellow. All right, so we have to differentiate that, so that's just 4, right? We're swinging over the exponent. X squared plus 12 becomes 3. Differentiating x squared plus 12, that's just 2x because the 12 becomes 0, right? Now I put this in brackets to make it clear. Multiplying x plus 2 to the fourth power, subtracting. Now we have this x squared plus 12 to the fourth power. Now x plus 2 to the fourth power, we have to differentiate this. I'll square this in the orange, right? Multiplying by that, so we're swinging over the exponent, so that'd be 4x plus 2, right, to the third power, multiplying, well, x plus 2 differentiated, that's just 1, right? Because 2 becomes a 0 because it's a constant and it's just 1. I'll put the brackets around that. All over x plus 2 to the 8th power. We can do some rewriting here. So this would be 8x x squared plus 12 to the third power being multiplied by x plus 2 to the fourth power, subtracting. I'm just going to take this 4 and stick it here. 4 x squared plus 12 to the fourth power multiplied by x plus 2 to the third power all over x plus 2 to the 8th. Now we can do some factorization. I can take out a 4, right? Because there's an 8 here, and there's a 4 here, so I can factor out 4. I can also factor out x squared plus 12, and I can take it as close to the third power. And then I can also factor out x plus 2, and I can take that as close to the third power. right? So in brackets, that would leave me with 8 divided by 4. That's just 2x, right? Multiplied by x plus 2 minus x squared plus 12. All over x plus 2 to the 8. We can do some canceling out here. So we see there's an x plus 2 to the 3rd power and x plus 2 to the 8th power. So this cancels out. This would become 5. So we have 4x squared plus 12 cubed. And now in the inside stuff here, so that's 2x squared. So I'll just write it out. 2x squared plus 4x minus x squared minus 12 all over x plus 2 to the 5. So this gives us 4x squared plus 12 to the 3rd power. 2x squared minus x squared, that's just x squared plus 4x minus 12 all over x plus 2 to the 5. And we can do a quick step here, and that's we can just factor this guy here. So that would just be x plus 6, x minus 2, right? Because if you expanded that, x squared, then you get 6x minus 2x, 4x, 6 times negative 2, negative 12, all over x plus 2 to the 5. Yikes. So 4 times x squared plus 12 to the 3, x plus 6, x minus 2 over x plus 2 to the 5. And yeah, that's pretty much it. Hopefully this video helped. I know this might have been a little bit of a longer one, but I thought I'd just include it all. But yeah, let me know in the comments if this helped. And yeah, that's pretty much it.